Greetings from Bayfield, Wisconsin. My name is Dre Carl. I'm the Lake Superior Fisheries Biologist at Wisconsin DNR. Today I'm going to be giving you an overview of our coordinated lake-wide juvenile lake trout survey on Lake Superior. And you may remember me giving a similar talk at last year's meeting, but this talk is geared a little differently, and I'll be going over a preliminary evaluation of one of our likely new indicator metrics to evaluate the Lake Superior Technical Committee fish community objectives for lean lake trout populations. So Tom thought this would be a good fit to add into this year's meeting agenda. But I'll get more into that after I give a brief overview of this survey. And all the agencies contributing to this survey are listed here, including OMNRF, Minnesota DNR, Michigan DNR, Red Cliff TNR, and Wisconsin DNR. The Summer Small Mesh Survey has many purposes for each agency, but a common purpose, and the reason I've assembled all the agency data, is to provide an index of lean lake trout recruitment. Recruitment is a big deal in fisheries management, especially in heavily exploited species like we have in the Great Lakes. Not to mention that many of our established reference points for sustainable lake trout populations, such as annual mortality less than 42%, SPR less than 0.25, are under the assumption of at least stable recruitment. Also, since the LSTC developed an FCO for recruitment data from this survey, it's important to include as many areas around the lake as possible to develop a lake-wide index. This map shows all the survey locations since 1980 in black, and the locations sampled in the 2020 update in green. Wisconsin, Michigan, and Ontario were able to complete their respective surveys in summer 2020. If you can remember way back to then, that was when a lot of us were still under COVID restrictions. As you can see, just by looking at this map, survey methods vary greatly across all agencies, but we do our best to account for all these differences when summarizing data with the FCO indicator methodology. For example, the nights fished, the fixed versus random sites, different density of sites, and depths fished all vary for each survey. To begin accounting for these differences, results from each survey were filtered to only include wild lean lake trout, which we defined as having no hatchery fin clips, fish less than 450 millimeters, and only fish captured in the 2 or 2.5 inch mesh panels. This standardized each agency's net configurations and creates our standardized definition of a juvenile lake trout, at least for the purpose of this recruitment index. CPEs were calculated as number of fish per kilometer of net per 24 hours and summarized with the geometric mean. And just for your reference, after these filters are applied, we're looking at a distribution of lean lake trout with a modal age of about 4 to 5 years old. So you can kind of think of this recruitment index in terms of those 4 to 5-year-old fish. Pictured here in these box plots are the raw CPE data from the whole time series for each management unit. We need to take these with a grain of salt, though, as survey methods, habitat complexity, and many other factors, like I talked about earlier, affect catchability in each of these surveys. All these factors create situations where catchability is definitely not equal among the different management units, so they're not really comparable. That was basically the first big problem to tackle when the tech committee was coming up with the FCO recruitment indicator. However, it's still valuable to get a look at the data this way at the beginning. This figure shows the geometric mean CPEs for each management unit. The next few figures will be in the same format with a different management unit in each panel. MI2 through MI7 on the top 1.5 rows, then MN1 to MN3, then the 4 Ontario management units, starting with Thunder Bay and working their way down the lake. Then the Wisconsin management units on the bottom, and WI2RC represents the independent Red Cliff survey and unit WI2. It's kind of hard to observe trends in CPE with data displayed like this, so I'm going to switch quickly to the next slide. These are the same exact data, but with a less regression fit to this recruitment CPEs. And this is just a nice, easier way to visualize a smooth trend for each management unit and to start identifying common occurrences. First, most units do show an overall increasing trend in recruitment throughout the time series. MI2, MI3, MN1, 2, and 3, and WI1 and WI2 are all pretty good examples of this. We don't see this in Ontario or in Ontario management units, likely just because the time series doesn't go far back enough in time. Second, many units have a stable or even decreasing CPE in the middle of the time series, in that 2000 to 2010 decade. MI3, MI5, all the Minnesota units again, and WI2 are all pretty good examples of this. Lastly, 2019 and 2020 surveys appeared to have higher than average recruitment indices, and you can see that trend line really spiking up near the end of the time series in most of the US units. So even though we have some common trends occurring with independent units and surveys, it was another hurdle to figure out how to summarize all of this into a meaningful metric for both management and the public in the form of an FCO indicator. Something to help get away from the well, it depends explanations, but something that's robust enough to provide some sort of substance. This is a summary of what the Tech Committee produced in the end to tackle this issue. They started off by determining that the trajectory of recruitment may be more informative than comparing to past benchmarks. In other words, a recruitment index in itself can't independently be used to assess population status, because things like within population density dependence can affect recruitment levels. So their overall goal with this FCO indicator was to measure the average rate of change for recruitment within reporting periods, which will hopefully provide some more meaningful information to managers. The actual FCO states to have a stable or increasing average rate of change for the geometric mean CPE of wild Dean lake trout in the summer survey. So how is this accomplished? With everything grouped within each state of the lake reporting period and management unit, a linear regression of log transformed CPEs by the survey year was built. In this rendition, each regression model was required to have a minimum of 3 surveyed years within the reporting period, which really just helps eliminate those instances where you're fitting a line between only 2 points. The linear models were weighted by inverse standard deviations of the recruitment CPEs. After all models were completed, the slopes were back transformed. If a slope was greater than 0.1, which indicates a positive 10% rate change, the management unit received a score of 1, and likewise if the slope was less than -1, it received a score of -1. And if the slope was between those -0.1 and 0.1 benchmarks, it received a neutral score of 0. If you're a visual person, these examples on the slide might help you picture the system. At the end of it all, the mean of all the scores is calculated, and if the mean is 0 or higher, the FCO objective of stable or increasing recruitment is met. Here's a figure to help everyone kind of visualize this first part of what's going on. Again, each management unit is within each individual panel. Now each state of the lake reporting period, basically a 5-year period, is a different color. So a linear model was fit for each period of management unit, which was around 75 models for this time series starting in 1990. And I simply just started this at 1990 because all agencies besides Ontario had started the summer survey by then, making it the most complete data set. If you want to zoom into MI4, it gives a good example of all the outcomes that could occur through time. This first time period looks like a negative slope or score of -1. The orange period is likely a neutral slope, or a score of 0. Then another negative, -1, another neutral, score of 0, and then a couple positive slopes that likely get scores of 1. This graph is showing the scores given to each management unit within each of the reporting periods in the panels. So each unit gets a score of 1, 0, or -1. The mean of each score for the reporting period is represented by the blue lines. So this FCO metric indicates we had a couple periods of increasing recruitment in the early and late 90s, then a couple periods of stable recruitment in the early and late 2000s, followed by a couple periods of increasing recruitment in the early and late 2010s. And I'll add that we still have one more year of data to add to this current reporting period, so this isn't the final number for this last recruitment score. In the end, this recruitment rate of change metric was pretty similar to those trends that were pointed out on the CPE figures at the beginning. There are pros and cons to using only management units with at least 3 survey years within a given period. So here I just did a quick comparison of the end recruitment scores between methods using a minimum sample size of 3 in green and no minimum sample size in orange. These two methods actually showed an overall similar pattern, which tells me that even when incorporating data from data-limited periods in time, this recruitment score methodology is still pretty robust. However, we might see a few less of the extremes if using a minimum sample size, such as here in the 2006 to 11 period and in the current period. So the minimum sample size method will likely work pretty well. Another related question was whether the standard 5 years of a state of the lake reporting period is a long enough time series to provide a meaningful and robust recruitment score. So I followed this up by doing the same scoring methodology, but with grouping the scores by decade instead of the 5-year reporting periods, with the assumption that more samples within a given time period would produce a more robust score. And as you can see, the scores by decade end up following the overall same pattern as the reporting periods, with increasing recruitment in the 90s, stable recruitment in the 2000s, and again increasing recruitment in the latest decade. However, just like you'd think, calculating these scores by decade ended up producing several more neutral or 0 scores rather than the extreme 1s and -1s. So just to leave you with a few takeaways, wild lake trout recruitment appeared to be increasing in the 90s, stable in the 2000s, and increasing again in the recent decade, which pairs with the overall increasing trend in recruitment over the full time series in many of the management units. The recruitment score FCO metric appears like it'll be pretty robust and useful for management. It's also pretty intuitive, so I can imagine myself as a fishery manager being able to reference this recruitment score when talking to stakeholders if they're ever interested in how lake trout recruitment is faring lake-wide. However, some of the finer details of the method, for example the slope benchmarks, likely continue to be evaluated as we start to compile data for the next State of the Lake reporting period. And with that, I think I'm going to be available for any questions. Thanks for your time.